So, good morning. My name is Hanno Van Raalte. I'm Product Manager for Moldflow. Welcome to our webinar on what's new in Moldflow 2018.0. This is the first release, or the third release in a row that we actually provide a quarterly update. We started in this quarterly cadence in the October timeframe, where we delivered our Moldflow 2017 R2, and then it was followed in the January timeframe with the Moldflow 2017.3 release. So this is the first one in a row that we're delivering new content in a quarterly release. We grouped the functionality we provided in this release in 3 areas: market impacts, technology leadership, and productivity, and user customer intimacy. I will go through these during this presentation in a bit more detail. So the first one is basic market impact, and what it means is basically develop new features, new functionality, or provide new technology that our customers can use to analyze more type of problems. So on the first feature in this particular area is that we made Moldflow Insight on a Moldflow Insight Ultimate subscription license. We provide access to Helius PFA. So Helius PFA is our structural interface to abacus and ANSYS, where you can take the file orientation that we have developed with Moldflow Insight and calculate nonlinear mechanical properties on that and make them available to structural analysis, so that you can look at nonlinear problems and look at when failure occurs on your plastic part. Also includes things like weld end strength prediction we introduced earlier this year. But this is available to the Moldflow Insight Ultimate subscription customers. So if you have a license that's a maintenance license, or Moldflow Insight Ultimate, you will not have access to it. If you have a subscription or term-based license, you will actually get access to this technology. The other thing we did is we basically synchronized the Moldflow database with the Helius database. So if you make changes to the database or you make software changes on the Moldflow side, it will also automatically be synced up with the database or the functionality Helius. So that we use up-to-date pre-correlations on the Rombook Osgood parameters, RO parameters in Helius that match the fiber orientation predictions in Moldflow. Another big step we made in this release is that we provide new capabilities in terms of optimization and Linux support. So we improved the large model deformations that we provided in the model deformation we provided access to in the 2017.3. We made it much more robust and quicker. So you can actually make much larger deformations. In this particular case, example over here, I moved the boss from the edge of the part all the way to the inside of the part in one modification step. Those sort of extremely large modifications would have been unsuccessful in prior releases. So a lot more robust, a lot more dependable in that sense. So we also support now the deformations on the CAD geometry through API. So if you have like a third-party optimization code that you want to use for optimizations, you can actually use API calls that we have in Moldflow now to drive those design changes fully within Synergy. So you can use third-party optimization codes to true optimization of plastic parts. And then we added the design optimization also now for Linux. So if you are using the design optimization technology, you can also run those parametric studies on your Linux machines. In terms of technology leadership, so one of the main features that we developed in this particular release is the ability to start analysis directly from a CAD model. So this is an area that we've worked towards for many years, and it basically means that before we can actually do this, we need to make sure that our meshing is as robust as we can make it. So in this particular video, I'll import the CAD model, I put an injection point straight on the part, And normally I would always say, like, let's say after you set up your analysis, you have to go first to a meshing step, after which customers typically like look at like, how good is the mesh before submitting an analysis. But now I can, after I put my boundary conditions straight on the partner injection point, straight on the CAD model, I can start running the analysis straight away, and the meshing and the analysis run in sequence there. So it's for, if you're an expert user, it helps you actually to improve your throughput. So let's say you have to run an analysis quickly overnight. You don't have the time to wait for your meshing to be finished before you can start your analysis. So you can actually start now running the analysis straight from the CAD model. The other way that's helping is, like, if you're a new user, it's much easier to get up to speed on how to learn how to use Moldflow. That being said, all the other meshing paths, or the meshing traditional meshing paths that we've had in the past, are still available. You can still, like, if you want to import a CAD model, mesh to a dual domain mesh, do all kinds of mesh checks that you want, and then go to a TED mesh and then submit your analysis. All those workflows are still fully supported, but you have an additional way now to run analysis. Myself, actually, I had a big need for it, like late last year, where I needed to create a very nice video with a nice smooth flow front, which basically means I have to create a very dense mesh. I had to do that overnight, and I started the meshing like around 11 o'clock in the evening, and I had to wait for like a fair amount of time before I could actually submit the analysis and go to bed. So this way, I can now take the initial CAD model, put the boundary conditions on it, specify which process the meshing parameters I want, and start the analysis straight on the CAD model. There are still some limitations there in terms of things like cool FEM is not directly supported. Valve gates are not supported in this particular workflow, nor are 3D hot runners, because particularly the last two of them, valve gates have to have boundary conditions set up, or on the last elements of the gate, that causes issues in terms of the mesh preparation at that point if we were to have a fully CAD-based workflow. And another limitation in terms of the 3D hot runners is that we would have to assign certain parts of the runner system that's combined with the 3D CAD model as a hot runner, and some other part as the solid body as a part. We know how to solve this problem. We will definitely try to resolve those shortcomings over time, but that in the first release, that's a limitation that we have. Another limitation is that we do not support structural constraints just yet. However, like I said, these are things that we're aware of, and we will try to resolve. Another thing that we did this release cycle is that we added updated support for 3D connection devices. We became aware of the fact that some of the newer 3D connection devices with the newer drivers were not working within the context of Moldflow. We identified what the problem was. We updated the driver support now for all the newer 3D connection devices on driver 10.x. In terms of productivity and customer intimacies, we added some new simulation capabilities inside of the Moldflow product, specifically for process that is becoming popular in the automotive industry in Japan and China and Korea. It's called multi-barrel injection molding. So, and the process basically means that you have multiple injection units injected straight into the part. So it's one cavity injected with multiple injection units that can be controlled individually completely. So they can have different, let's say, melt temperatures, different injection profiles, different barrel sizes and such. So we got requests to support this this fairly complex process. And if you think about it, with new complex processes that are coming to market, there is insecurity in whether or not this is the right decision now or not. And simulation can help bridge that gap in terms of building confidence that this technology is viable for the application that you have, and then it's going to pay back. So we support this now for mid-plane, dual domain, and 3D models, and we get really good feedback on the initial development. We also completed some work on the compression molding side. The first step was basically the support for the injection molding combination with an overmolding step. So in the prior release, we actually had compression molding first and an injection overmolding, and we did not support the inverse operation. So now we have the ability to actually do an injection molding first and do a compression overmolding on top of that. The second enhancement in the compression molding side is that we also calculate the heating up of the charge while it's sitting in the mold before compression starts. So a lot of times when you place a charge, it will sit there for a couple of minutes or a couple of seconds. The areas that are in contact with the hot steel will heat up and create a hot area that might actually start experience curing already before the compression starts. So now we actually properly take it into that's sitting time in of the charge in the mold into account in the conversion and properly taken into account in the simulation. We also provided a new API call specifically for the solidification of thermoplastics. So this was an enhancement we got from a request we got from one of our partners to support a new, more experimental way of solidification that hopefully is going to result into some improved voltage predictions down the line. So we open up the API call for that inside of the solver, and the end customer can actually make some modifications in the way the solver behaves. We've released several of those components, solver API areas, to in the last couple of years, and we will continue to do so because it really helps us work with advanced partners or universities to develop new areas where we have new theories come to light. So yeah, that works really well. So this is, like I said, this is the third release where we basically made new functionality available. This release also we did a lot of under the hood work in terms of integrating a lot of new components. So in terms of the feature set, the 2018.1 release is not as big as you would have normally expect with a 2.0 release. Let's say the 2017.0 release was to some extent a much larger release than 2018.0. But you have to remember that throughout the year we've had a lot of deliverables made available at a quarterly basis. So yes, the 2018 release on its own is not as big as it used to be, but we delivered a lot of technology throughout the year in the last 12 months, and we'll continue to do so. So we've already started working on some new functionality, exciting things that we hope to make available in the 2018.1 release in the July timeframe. With that, I'm opening the floor for questions.
Great, thanks so much, Hanno. So we do have a couple questions here. The first is, does Helius install together with the Moldflow installation?
No, good question. No, it is not included in the installer, but it's a very good question. So if you have Moldflow Insight Ultimate on an MUS or subscription license, you should be able to see Helius as an area in the product download section as an entitlement view. So there's a separate download that you should be able to find on Autodesk accounts. It does not automatically install with Moldflow Insight.
Great, thank you. And another question we have here is this considered a major release, or will it run based off the last 2017 R3 release?
Can you repeat the question? You're breaking up.
Yes, absolutely. Sorry about that.
Can you repeat it?
Yep. So we have a user who would like to know if this is considered a major release or if it will be run based off of the last release, which is the 2017 R3.
Okay. Okay. So I think we have to be so going forward. So like I said, we are now moving to a quarterly release schedule. So we are now not necessarily looking at the traditional way of releasing software is once a year we make a lot of technology available, and then throughout the year we do service packs to sort of improve the code. Now every quarter we basically do a combination of making new functionality available when we have developed it, as well as doing bug fixes in that same time frame. So the old paradigm of a major release followed by service packs, we've moved away from that, and now every quarter we release new functionality. So we may over time switch to a slightly different release paradigm along the lines of a major release, a minor release, followed by a major release and a minor release again, sort of alternating a little bit. But we're still in a bit of a transition phase there. So, but like I said, we are working on components throughout the year that we hope to make available when they are ready and not before that.
Thank you, Hanno. Another question here. Have any improvements been made with the 3D runners from models brought in from CAD? The interfaces do not mesh well together, even with precise match and local matching mesh densities on the contact surfaces.
Okay, good. Not yet. It is definitely an area that we do want to make an improvement on. So I think if I can restate the question, is like if you have a CAD body of a part and you bring in a CAD body of a runner system and you connect them together, and you mesh them you want to mesh them in 3D. You do want to automatically connect the two CAD the meshes of the CAD bodies together and make sure that they're continuous. We've not resolved that one yet, but we do intend to work on that in the foreseeable future. So we have a couple of other things in the pipeline that we're working on that at the moment take priority, but this is definitely an area that we know we can do a better job at than what we have done so far.
Great, thank you. One more question we have here is basically, will the 3D Space Mouse now work in the 2017 version, or will the user have to move to 18 to have that functionality restored?
No, and it has to be in the 2018 release. Yeah. Make sure that the drivers are up to date as well. I think there are two old Space Mouse devices that are no longer supported, that are also no longer supported by 3D Connection itself.
Great, thank you. And I don't see any other questions right now. We can give everyone another minute or two, but I know, Hanno, one thing we can add is to have them take a look at the What's New section that can be found as a PDF with the Moldflow install files. Is that correct?
Yeah, so if you go to the help section, there is a section in the online help that specifically talks about what's new in a lot more detail than I have done so far. There is also going to be available a validation document that I'll also circulate on the Autodesk accounts in the product update section, I believe it's called. It's going to take a couple of days to get there, but I have the content ready for it. If you need access to it urgently, just send me an email. I'm happy to send it to you directly. One more thing to point out is that even though it's not called out specifically in this presentation, we solved around 150 long-standing bugs, as well as about 50 things that we saw coming up in the last year or so. So even though we provided a lot, we updated a lot of content in this release, we also spent a lot of time on bug fixing here. So.
Perfect, and that actually coincides with another question we just got, if there is an actual list of these captured bugs in the new release.
Good question. I don't think so, but I think that's a good point. We actually should take that into account in making sure that we capture all those bug fixes in the release. We've done those in the past, in prior years. That being said, I found it fairly hard to. So a lot of times we get a bug reported in a specific way, and the title of the bug is not very descriptive of what it actually is. We will. I'll see what we can do in terms of capturing the list of fixed bugs for this release. Probably not for this release, but going forward. It's a good point.
Great, thank you. And that seems to be our last question listed at the moment. So with that, if there's, looks like we have one more here. When will Moldflow offer more meshes like hex meshes for runners like Moldex and SolidWorks plastics?
So that's a good question. We get the question fairly often, and the question typically comes from relates to competitive codes, and typically from people that are very familiar with structural domains and really do have a very severe dislike for TEP meshes. But for our problem type, the TEP meshes work really well. So even though we do a structural solve on the Moldflow side, even though that is a structural solve, the mesh type that we actually support in Moldflow are very well suited for the types of problems that we're throwing at it. So I don't think there's a specific need for us to work with hex meshes. Hex meshers have, like I said, they look very cool and no doubt, but at the end of the day, if there's no benefits to be gained from it, then I don't see why a good reason to actually include them and put a lot of effort into creating those. The other thing is that it's not always simple to create pure hex meshes. So hex dominant meshes are fairly common, but so at the moment I don't see us implementing a hex mesher inside of the Moldflow domain.
Thanks, Hanno. So I think that is it for now. And again, thank you very much for sharing all this information with us. And again, this will be posted to our YouTube channel, as well as a link will be sent out with the slide deck that'll be uploaded to our Autodesk box folder. And with that, I think we've shared all of our information today. So thank you everybody very much for attending, and thank you, Hanno, for sharing this information with us as well.
No problem. Everybody have a good day.
Great. Thank you.